Hello, Gaudi class. I hope you had a good half term and are eager and enthusiastic to get back to work. Today in maths, we're going to be looking at how to recognise odd and even numbers. And by the end of the lesson, I could give you a number with 42 digits in it, and you would know whether it was odd or even. I'm not going to, but I could. You would know any number. You'd be able to look at any number in the world and know instantly if it was odd or even. That's a challenge, isn't it? Okay. So these are our even numbers. And the great thing about even numbers is we can count them in twos. So these are our twos, aren't they? 2, 4, 6, 8, 10, 12, 14, 16, and we keep going 18, 20. But that doesn't help us because, like I said, if you can know that any number is an even number. But if you look, you'll notice if you just look at the ones digit that the pattern repeats. So here we've got 2 and here we've got 12. So the answers both end in 2. We have 4 and 14, 6 and 16. And we have also, I left out the 0 and the 0. So actually, there are only 5 numbers we need to know, 5 digits we need to know whether a number is even or odd. So as long as we can do the first 5 numbers in our 2 times table, starting with 0, 0, 2, 4, 6, and 8, that can tell us whether any number is odd or even, because all you ever need to do is look at the ones digit. Any other digit is a multiple of 10 or 100, and 10 is an even number. 100 is an even number, so we don't actually need to look at the tens, we just look at the ones, and that will tell us if a number is odd or even. So these ones, the ones we can count in 2, 2, 4, 6, 8, 10, 12, 14, 16, they're all even. And the ones in between are our odd numbers, 1, 3, 5, 7, 9. And again, 11's got a 1 in the ones digit, 13 has got a 3 in the ones digit, 15 has got a 5 in the ones digit. So it's those numbers that make it odd. So we're going to have a look at these ones. We've got all the numicon, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, we're not even going to look at what number they are. We're going to look at whether we can see straight away whether they are odd or even. So I explained to you before when we were counting in twos that even numbers have partners. So you can see this one here, these two have partners. If you take this one here, the 8, this one has a partner. It's partnered with this one here. These two are partners, these two are partners, and these two are partners. So they are even numbers. The ones that have the one sitting on its own, the lonely, lonely one, like the 7 here, where it's got no partner, those are odd. Okay, so I'm going to point to one, I'm going to go across the screen and then down and across, and you're going to shout out whether it is odd or even, and we shall try. So, odd or even? Okay, odd or even? Ooh, it is not, it is even, well done. Odd or even? Excellent, we can see from the bit that's sticking up at top that it is odd. We have 5 over here, odd or even? Excellent, because it's got that bit sticking out at the top. Odd or even? Even. Odd or even? Excellent. Odd or even? This is 7. Even. Oh, no, it's not. Odd. Odd or even? Odd or even? And again, we can see because it's got the bit sticking out at the top, and 10 is even. So our numbers go 1, odd, even, odd, even, odd, even. It's like a pattern that goes on forever and ever and ever. So we've got some children here, and we've got 2 groups. So what we're going to do is we're going to share the children between the groups. So I'm going to have one each here, and I've got one here, and one here, and one here. Okay, I've shared the same children twice. So have I shared it equally? Have I got any left over? No. So I have shared them equally. So this is 8 children is an even number. There aren't any left over. There aren't any missing. Now I've got 5 flowers, and if I share these equally, so I'm going to put one here and one here, and then one here and one here, I've got one left over. I could put it here, but then they wouldn't be equal because I would have 3 here and 2 here. So I leave this one out. So this one is odd because I've got this one. It's an odd one out. It's on its own. So we have an odd amount of flowers. Okay. Right, so this is what I was telling you about knowing your even numbers. So we're going to count in 2. So we have got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And if we weren't sure, we go back to the beginning. So now we've done 20. So we've got 2, 4. So we've got 22, 24. So it'll always be the same, 26, 28, and then it'll be 30, 32, 34, 36, 38, 40, 42, 44, 46. So you can tell. So if I gave you the number 194, all you would have to do is look at the ones digit. Does that come into the 2 times table? 0, 2, 4? It does. So yes, that one is even. I could give you 2,461. Yeah, it's a thousands number. We don't even do thousands numbers in year 2. And all you would need to do is look at the ones digit. Is that in the 2 times table? 2, 4, 6? No, it's not. So that would be an odd number. So this one here would be even. And you could go on. I could give you a number. So shall I give you a millions number? And you can tell me if it's odd or even. So I'm going to say 3,496,523. And you're going to be able to tell me if a millions number is odd or even. So just look at this one here. Is that an odd or an even number? It's an odd number. You could try that one on someone at home. You could say, give me a number that's got 7 digits in it. Give me a millions number. Give me a thousands number. And I'm going to tell you whether it's odd or even. And they'll be very impressed when you can do it. Just remember to look at the ones digit. Let's get back to what we're supposed to be doing. So using the pattern above, this 2, 4, 6, 8, we're going to write the numbers that come after 30. So if we had 30, we would then have 32, 34, 36, 38, and then we just need to know what the next 10 is, and that's normally where it gets a bit tricky, so that's 40. And then the same again, so 42, 44, 46, 48, and then we just need to work out what the next 10 is, 50. And we would carry on and on and on. Okay, so Tim here says he has made all even numbers. You don't even need to count how much he's got. I can tell you it's 12, 14, 16, and 18. Doesn't matter. You can just look and you can see whether or not they are odd or even numbers. And he is correct because we can see we've got no numbers left out on their own. All our numbers are in pairs. So like I said, it's very easy to check whether a number is odd or even. And you know me, I don't like using the word easy, but it is easy. So you can see if the ones digit is in the 2 times table, or you can just look and see, is there an odd one out? Are they in pairs, or is there an odd one out? And that's all it is. If there's an odd one out, or if it's not in the 2 times table, it is odd. And if they're all in pairs and they're all happy and they're in the 2 times table, then they're even. And all you have to remember is which way around odd and even goes. So, your challenge for today. So Eva uses counters to make numbers from 1 to 10, you can see. And all you've got to do is tell me which ones are even. And so the even ones will not have an odd one out. So the even ones will all be in pairs. So you can just tell me which ones of those are even. And what do you notice? And I think I've just told you what you notice. They are all in pairs. So which ones of those are even? And the next one here is we have got 16 shoes. And all I want you to do is I want you to prove to me that's an even number by putting them into 2s and showing me that there are no odd ones left out. And then you're going to do exactly the same here with the 17 socks. You're going to group them in 2s to show me that there is one left over. So there is an odd one out. And that's all you need to do. So just you could do it if you can't draw shoes and socks. It's just drawing circles. So you could draw 16 circles. I don't know what happened there. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And you could just group them in twos. And you can see there aren't any left over. And you could do the same with the 17 to show me that there should be one left over. So we know this one is even, so there shouldn't be any left over. And this one is odd. There should be an odd one out. There should be one left over. Challenge 2. Okay. Teddy has a 2-digit number. The first digit has been covered up, and that's the second digit. So is Teddy's number odd or even? And how do you know? So do you know? Is it odd? Is it even? You don't know? And how do you know? And down here, we've got some numbers. Some are odd and some are even, and some are in the wrong place. So can you just tell me which ones are in the wrong place? You don't need to write them all out. You can just say, if you think it would be 1, you can just say 1 should be in the evens, or 1 is in the wrong place. Okay, it's not, by the way. And the next question, this time you've got a 2-digit number and the second number's been covered up, and is Dora's number odd or even? And you should have the I can't tell. What did it say on the last one? You cannot tell. So you should have a you cannot tell there. There you go, you cannot tell. So is it odd, even, or you cannot tell? And explain your answer. And just say, I think it is odd, even, or I can't tell. And okay, challenge 3. Dexter makes 70 from base 10. You've got 10, 20, 30, 40, 50, 60, 70. Okay. So 70 is, and he says 70 is odd, and you can't share it into 10 groups. And if you look here, you can see that there are 7 10 sticks. So you can't share 7 into 10 evenly. You can't. But can you share 70 equally? So what mistake has he made? It's a kind of complicated one. You might have to think about that one. Okay, number 6. Whitney's making a number pattern. And you've got the middle numbers there. You're missing 1 at the beginning and a 2 at the end. So you've got to write in the missing numbers. Then you've got to write in 2 numbers greater than 30. That means bigger than 30. That could be in the pattern. Okay, so we're doing odd and even numbers. Are those numbers even or are those numbers odd? So can you do 2 of those numbers that are bigger than 30? And then could you do 2 numbers bigger than 60, greater than 60? That could not be in the pattern. So if you think this pattern is even, then those would be odd numbers. If you think the pattern is odd, those would be even numbers. Okay. And the extension. I love this one. Roll 2 dice. And if you haven't got 2 dice, you can just pick random numbers. It's fine. So if you've got a phone or a computer, you can actually get a random dice roll program. You just Google roll a dice or roll 2 dice. So roll 2 dice and find the totals. So dice 1 was 3, dice 2 was 2, add them together, 5. So the total is odd. So this one, dice 1 was odd, dice 2 was even, and when they added them together, it was odd. So play that for a while to keep rolling the dice. Maybe you could play it with a game, maybe you could play it as a game with somebody else and see what you get. So who's the first one to get 5 odd answers, or who's the first one to get 5 even answers? You can see. So what patterns do you spot? So when you add an odd and an even number, the total is, it says it's always odd, but is it always odd? You might have to do a few to just check, is it always odd? And what other statements can you make? So what about if you had an even and an even number, or if you had an odd and an odd number? So that should keep you busy for a little bit. I hope you enjoy that game, and I look forward to seeing your answers on Tapestry.